All right, so I know there was quite a bit of confusion on certain things when we were dealing with this in class. I know some people had to miss class or might not have been there for the lesson. So I wanted to create a quick little video to kind of give you some extra help if there's any parts of this lesson between Friday and today that is giving you some trouble. So I'm going to work through all the steps in 2 different examples, and then hopefully that'll give you a little better feel for what it is that we're working on and how to approach these problems for yourself. So I'm going to start with domain and range. So remember, the domain is our X values, the range is our Y values. So one of the things that troubles us with domain and range is that we are only seeing part of a graph. If you remember, the arrows on our coordinate grid are reminding us that those are going to keep going on and on forever. Same with our graph. When you see those arrowheads at the end of our graph, our lines, those lines are going to keep going. And you got to picture them going and going, like they're going to continue on and on and on and on. So if that's the case, this graph is going to continue to grow and grow and grow and grow and grow. So there's a lot more numbers involved in this graph than what we're looking at right now. So one of the things we did in class is we gave ourselves some reminders. On my x-axis, as I move towards the positive direction, I've got 1, 2, 3, 4, but if I kept going, I would eventually head towards infinity. Same thing in the negative x direction, negative 1, negative 2, negative 3, negative 4, I would eventually head towards negative infinity if I were to keep going. So if this graph got bigger and bigger and bigger and bigger, I would keep going farther and farther out there. Same thing with my y-axis. As I go up, I'm headed towards infinity. As I go down, I'm headed towards negative infinity, just so we can kind of keep the two of them separate. So for my domain, my x values, so I always put them on my brackets, x such that, and then I want to describe the x's that can go into this function. So I can see a lot of negative 3, negative 2, negative 1, 1s, 2s, 3s, but remember those lines at the end of those graphs? Those graphs are going to keep going. And it doesn't look like they're going very far, but imagine they go on forever and they keep going and going. They're getting wider and wider and wider. They're getting farther and farther in each direction in that x-axis or along that x-axis. So there are literally every x would eventually get touched by this graph. Okay, those lines would keep getting wider and wider going to the left and the right. So I could go all the way out to negative infinity. I could go all the way to positive infinity with those x values, and they would all be part of this graph. So for this, we're going to say x is all real numbers, meaning any number you can think of, positive, negative, fractions, decimals, big, small, doesn't matter. They would all fall along that line. They could all be part of this graph if we kept getting big enough. The range we have to be a little bit more careful with. Okay, so as the graph is going up, those y values are going to go all the way up to infinity. So those y's would keep getting taller and taller and higher and higher. But as we head down on the graph, notice it doesn't keep going all the way down to negative infinity. It stops. Here it kind of gets capped at negative 2. It never gets lower than negative 2. It gets higher than negative 2, but never lower. So for my range, I would say y such that y is greater than or equal to negative 2. Basically saying negative 2 is the lowest y goes, but I can do everything that is bigger than that. Okay? So hopefully that helps a little bit with our domain and range, how far those numbers are going to spread. Then we have our X-intercept. So X-intercept is where it crosses the X-axis. So every time it hits the X-axis, so these green points down here, that's one of my X-intercepts. So the very far left one, it crosses at negative 2, 0. Then it crosses again at negative 1, 0. Then at positive 1, 0, and positive 2, 0. You're listing all the different spots that it crosses the X-axis. Now our Y-intercept is just that, where it crosses the Y-axis. In this case, it only crosses at one point, and that's the point 0, 4. Okay. Now we have something called the relative maximum and minimum. So relative maximum and minimum, I kind of talked about in class, is kind of the peaks and the valleys on a roller coaster. So the overall graph might eventually go beyond these points, but at certain points in the graph, we kind of hit this point. So like, for instance, this yellow point in the middle is going to be a relative maximum. It's kind of the high point along the graph. So that relative maximum would be 0, 4. It's where that highest point of that graph happens to be. Now I know on the edges it's going to keep going on forever, so that's why it's called the relative maximum. It's kind of that point within the graph, that high point, that top of the hill. The minimum is kind of our low points, the lowest that this graph is going to hit. Okay? And in this case, we've got 2 of them here. Okay? And just for simplicity's sake, I know what the graph looks like. It goes just a hair past -2 for y. Let's just call it -2 so we don't have to confuse ourselves with being overly specific. But it kind of crosses right in the middle of -1 and -2 and goes down to -2. So I'd call that -1.5 and -2. And then on the right-hand side, on the positive side, it goes the positive 1/2 and then down to -2. So 1.5 and -2. Those are my minimums, the low points of them. Sometimes there's just one in the middle. In this case, there happens to be 2 of them there. But the relative maximum and minimum are kind of that highest point and lowest point within the middle of the graph. Okay, kind of those peaks and valleys of that roller coaster. All right, so now we get to some of our other vocabulary. So I'm going to use my highlighter to help with this part. So increasing, I want to know where is my graph increasing, meaning going up as I go from left to right. So it would have a positive slope. So this little chunk of line and then this little chunk of line are both increasing. They're going up. So when you're describing a chunk of the line, you're just telling me its endpoints, the x values. So you're focused on the x values of these points. Where do they begin and end? Well, it begins here. We're going to call that -1.5. And it increases until we hit 4. So between -1.5 and 4, oh, sorry, I totally messed it up. We want this point up here, which is at 0, so -1.5 and 0. Remember, we're always focused on those x values. I even tripped myself up. So between -1.5 and 0, the graph is headed upward. It's increasing. Then I have another section where it's increasing. It starts down here and then continues up this line here. Well, it starts at +1.5, but notice how it's just going to keep going and going and going and going and going. That's going to go all the way out to infinity if I were to keep going. So from 1.5 to infinity on the x-axis, my graph is increasing. Then I have decreasing, so when the graph is going down. So I have this little piece here, and then this little piece here. So let's start out here. Notice this part out here. If I were to keep going, it's going to go on and on and on and on, all the way in that left-hand direction, which is -infinity. So it's going to start all the way out there at -infinity, and then come back to my point here, which is -1.5. You'll notice that the increasing starts where the decreasing ended. Then it's going to do the same thing again. It's going to start here and decrease down to here. Well, that's an x of 0 out to an x of 1.5. Okay? So you're describing the range from the left end to the right end of where that line is increasing or decreasing, whether it's going up or going down. All right, so now I'm going to switch it up. And we talked about positive and negative. So positive and negative is not the direction it's heading, it's where is it in relationship to the x-axis, the horizontal axis. So anything above the x-axis is positive. So this part of the line is positive. And this piece and this one are all positive. Okay? So let's describe those chunks. Let's start with this chunk here. It starts all the way out here. Remember, it's going to keep going on and on and on. So that's -infinity. And it stops at -2. Then it starts again at -1 and continues all the way until +1. So from -1 to +1. And then it starts again at 2 and is going to go on all the way to the end. So 2, and then remember, if it's going all the way out there forever and ever, that's going to hit my infinity. So 2 and infinity. We're describing the endpoints of that section of the line. So notice up here, when we were talking about the minimum or the maximum or the intercepts, those were specific points. So we are giving the coordinates of those points. Down here, we're describing chunks of the line, sections of the graph. So we're just giving the endpoints. It starts on this on the left and heads to this on the right. So let's look at where it's negative, below the y-axis. So that's these two chunks here. And again, give me the endpoints. Well, it goes from -2 and ends at -1. -2, -1, okay? Those are the endpoints for where it's in the negative territory. Then over here, it heads to the negatives here and stays in the negatives until here. So from +1 to +2, okay? And you'll notice the positive ended at -2 and the negative started at -2. The negative ended at -1, the positive started at -1. So one endpoint leads right into that next category. All right, I know that's a lot, but hopefully seeing it explained a little more can help a little bit. Now we want the axis of symmetry. So axis of symmetry is basically splitting it down the middle, so we would have two equal parts. Well, in this case, if I were to split it right down along the y-axis, I would perfectly split that graph in half. They would be equal halves. So the line that I just shaded goes through x of 0, so my line of symmetry is x equals 0. Okay. And then the last one, f of 1, meaning what is the value of the function at 1? Meaning I'm going to put in 1 for x, I want to know what I'm going to get for y. Well, here's f of 1. I put in 1 for x, and I got 0 for y. So f of 1 is equal to 0. I plugged in 1 for x, and I got a value of 0 for y at that point. All right, so I'm going to do one more. I'm going to go a little quicker on this one, okay? But just so you can see it again, I like to start by putting my infinities and negative infinities, because that visual reminder is helpful. My domain is my x's. Well, you'll notice my x's are going to keep going out this way and out this way forever. So I'm going to have x such that x is all real numbers. There are no x's I'm not going to use because it's going to keep going in both directions as far as I can. Okay? My range is my y values. So y such that y, you'll notice this time my x's are all headed up. They do go down, but they kind of stop and never make it lower than this. So that means y is greater than or equal to -3. That's the smallest it can get to. Okay. My x-intercepts, where I cross the x-axis, well, I've got a point here, 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 and here. Again, if you're talking about specific points, give me the x and y coordinates. So it crosses at -5, 0. Crosses at -1, 0. It crosses at +1, 0, and then +5, 0. Okay. My y-intercept is where does it cross the y-axis? In this place, it just crosses in one spot at the point 0, 3. Okay. All right. I'm moving a little quicker, just hopefully we've got a little better understanding of it. So now I'm going to do my relative maxima. A maxima is our biggest, so think of the top point somewhere in the graph. Well, I know on the edges it's going to keep going, but I want to look in the middle. Is there a peak in the middle of the graph? Well, I have a peak right here at 0, 3. It happens to be right at my y-intercept. My relative minimum are my low points. Think of the valleys, the lowest points it hits in the middle. Well, I've got two of those. I've got one right here and right here. So I've got one at -2, 0 and 2, 0. Those are both my lowest points. Okay. Now I want to look at where is it increasing, meaning going up. Well, it's increasing from here to here, and it's increasing from here to here. So describe where it's increasing. Well, it's increasing from this point, -2, to this point, 0. So -2, 0. And then it's increasing from here, an x of 2, all the way out forever, so an x of infinity, because it's going to keep going on and on forever. Now let's see where it is decreasing. So the line is heading down as we go left to right. So I've got two sections here. Okay. So this left one, all the way out here, that line would keep going on and on all the way to -infinity. That's where it starts, way out at infinity out there. And then it stops decreasing right here at -2. Then it starts decreasing right here again at 0, and then decreases all the way to here at x of 2. So again, notice it stopped, the increasing started at -2 because the decreasing stopped at -2. The increasing started at 2 because the decreasing stopped at 2. Okay? A lot of times those points are going to play more than one role. It's the end of the decrease, but it's the beginning of the increase, and vice versa. All right, almost done. Now I've got positive and negative. So now I'm not worried about whether it's going up or down. I just care about where is it in relationship to the x-axis. When is it above and when is it below? Well, here it's positive, here it's positive, and here it's positive. Those are all sections that are greater than x, or greater than 0, above the x-axis. Well, section 1, we start out all the way at -infinity and stop at -5. So -infinity to -5. Then this section starts at -1 and ends at +1. So -1, 1. And then the third section starts at 5 and goes out to infinity. So 5 out to +infinity. Okay. Now I want to look at where it's negative, where it's below the x-axis. So here's one section, and here's one section. Okay. So one of them starts at -5 and stays negative until we get to -1. So -5 to -1. Notice that's where one section of positive ended and one section of positive began, because it falls right between there. Then I've got another one that starts at +1 and goes to +5. 1, 5. So you're describing the range of x's that happen to be negative. Well, it's negative in between an x of 1 and an x of 5. All right. So now I'm going to look at my axis of symmetry. Where do I split this in half? Well, this one happens to be the same as the last one. If I split it right down the middle, right at x of 0, oh, sorry about that. Sometimes the computer gets away from me. All right, so x equals 0 is where my axis of symmetry is. Okay, that's that line that perfectly splits my graph in half. Okay, all right, hopefully that helped just a little bit. If you have questions, make sure to come see me. But otherwise, hope that helped.